Hello, welcome back. So in the previous part, we were discussing about the force and particularly the static force. Now we will discuss more about it because in our course, we will be dealing with this force only, which is the static force and its equilibrium. As I said earlier also, there are two types of force. One is the static force and the other one is the dynamic force. So our building experience both of these force. But for ordinary structures, we generally consider static forces only. Like when we design our building for the dead load and live load and the environmental load like the earthquake load, in that case, we generally consider dynamic part also. But as we are designing or we will be dealing with the ordinary building, so we will assume that our building is experiencing only the dead load and live load. And for that, the consideration of this static force is enough. So as written here, static force are those that can be dealt with without the need for consideration of the time dependent aspects. So basically dynamic force is the time dependent property. It is dependent on the time. It is basically dependent on the time. So whenever we notify this force, we always write the t because it is dependent on the time. So at one point of time, it may have different magnitude. At another point of time, it may have different magnitude. So this is time dependent, and that is why this is also very critical. But we are not going to consider this aspect because we are just dealing with the simple mechanics. So we will not consider this dynamic. We will consider only the static force. So the force that we are going to use in our course, it has a unit, and basically in SI system, we express our force in terms of Newton or kilonewton. In MKS system, unit of force is kg. In CGS system, I think it is dyne. So now we will see what are the properties of the force, because we will be learning more about it. So we need to understand what is force and what is the property of this force. So property of the force can be expressed graphically like this. Generally, we express our force as an arrow. Now, this part is called the head, and it gives us the sense. What is the sense of force? Now, this head can be upward, this head can be downward, this head can be rightward or leftward. So based on this direction or the sense, we express our force. So this is called head, and this part is called the tail of the force. Similarly, if we draw this arrow in scale, then the length of the arrow is showing the magnitude. What is the magnitude of the force? Now, magnitude can be in terms of Newton, can be in terms of kg. So for example, if I say that 5 kg force, in that case 5 kg is the magnitude. So 5 kg force will be drawn on scale, and that is why I am saying the length of force is showing the magnitude. So if I say that 5 kg force, the length of force may be like this. If I say 10 kg force, then 10 kg force will have double length arrow. Okay, so this is how we express our force graphically. Similarly, the line along which this arrow is going, that line is called the line of action. This is again a very important point. Line of action, the line about which the force, sorry, the line about which the force is acting, that is also very important. Similarly, then there is another property of the force, which is the direction. So this direction can be expressed in terms of the angle it is making from a reference line. Now that reference line, say in this case, it is a horizontal line. Just for example, I'm considering that this is the horizontal line. So how much angle this force is making from this horizontal line, that angle is expressed as a direction, or it is known as the direction of the force. If there is a vertical downward force and on this horizontal member, then we say that the direction of the force is 90°. If we say 10 kilonewton force, then this 10 kilonewton is actually the magnitude of the force, and the direction of the arrow is downward, so this is the sense of the force, which means it is the downward force. Similarly, there may be a upward force, so in that case the sense is upward. There may be a rightward force, in that case the sense is right. Okay, so this is how we can express our force, and we can see there are different property of the force. So I have written here, force has property, a very important property in terms of the magnitude, and magnitude is expressed in, I mean, amount of the force, it is measured in the weight units such as kg or newton or dyne. Okay. Similarly, it has a direction. So direction is expressed as the angle which force makes from a reference line. Similarly, then third very important property of the force is the sense. So sense is expressed by the head of the force. So the direction, so the sense of the arrow, it may be upward, it may be downward, it may be rightward or leftward. Okay. So that is the property of the force. Now, in addition to the basic property that we have seen in the previous slide, those properties of magnitude, sense, and direction, two other concerns are also there which are significant for the analysis of the structure. And now we will see those two concerns also. And those two concerns are very important in our structural analysis. Like the position of the line of action. Where is the position of the line of action of the force with respect to the line of action of other forces, or to some object on which the force operates or force is applied. Now we will understand this statement using the diagram. So in this diagram, you can see there is a force system in which three forces are acting. So you can see this is the active force which is acting on a horizontal member like this one. This horizontal member is shown by a horizontal line, and this force is applied on this horizontal line, and this horizontal member may be supported on the ends. So on the ends there will be some reactive force. As I said, that if there is a horizontal member and if it is resting on from its ends, then the load on the force, because of this load on the member, some reaction will be offered from the point where it is connected. So in the same manner it is happening here. Now the statement now we will read. Now the statement is about the position of the line of action. So in the first case, you can see the position of the line of action of this active force is near to this end, and because of that the reaction at this end is higher than the reaction at this end. Now why it is happening? Because the active force is near to this end, so because of that the reaction is higher. Similarly, if we place, or if the line of action is near to this end, in that case the reaction will be higher on this, and reaction on the far end will be the low. So the end, the end near to the active force is called the near end, and the other end will be called as far end. So generally far end will be having low reaction and near end will be having high reaction. So in the second case it becomes opposite to it. In this case this becomes the near end and this becomes the far end. Okay, so this near end and far end is based on the position of the line of action of the active force. So that is all about this statement. Now, the second statement that we will see now is about the point of application, where the force is applied. At which point, I mean, on which point a force is applied, it is all about that. So it says the point of application of the force along its line of action, which may be of concern regarding specific effect on an object as shown in the figure. So again, we will try to understand this statement. So in this case, you can see there are two buildings. Now, in the first building, force is applied on this member and it is applied on the center point. So you can see the point on which the force is applied will suffer more. So you can see the effect of force is most at the point of contact. So here maximum effect is there. Similarly, if we apply the same force on the same and on the other member, in that case also the point where the force is applying is having the most impact. So that is all about the position of the effect of force, where force is applied. Similarly, if there is a horizontal member, if we apply a force here and there are the supports on which this member is resting, so maximum effect of this force will be experienced near to this. So their effect of force will be higher as compared to this position. Those are the far end of the body. So the point of application where force is applied will have maximum impact of that particular force. So that is that is this statement is all about. Now, if we classify our force, now again, force classification is being done under the domain of this static force. And I would say that force can be classified on various bases. So here in the static force, I am classifying force in the three category. One is the coplanar force. Now, coplanar forces are those forces which are acting in a single plane. Now, plane means, like you can see, our space is generally expressed in three orthogonal axes. Like these are the three axes. Like if we consider that this is x-axis, this is y-axis, and this is z-axis. Okay, so our space is expressed in these three axes, and if we consider any two axes, so the plane formed because of those two axes becomes the plane actually. For example, if we consider z-axis as the vertical axis and y-axis as the horizontal, y and x-axis as the horizontal axis. So in that case, if I consider x and z-axis only, I forget y-axis. So in that case, the plane will be xz, which means this one. In that case, plane will become like this one. And all the forces acting in this plane will be called coplanar forces. Similarly, if I consider zy plane only, so zy plane and I forget x plane, so in that case plane will become this one only. So all the forces in this plane will be called as the coplanar forces. Then we have parallel forces. We may have many forces which may be parallel to each other. So if all the forces are of same direction and they are parallel, then in that case we call them like parallel forces. And if the direction of, if the sense of the force is different but they are parallel, you can see here this force is having different sense and these two force is having the same sense. So in that case we will call them unlike parallel force. So this kind of force system unlike parallel force system and like parallel force system, it generally occur in our analysis. So we need to understand what is this whole system about. For example, if we take an example of this horizontal member and it is resting on the support. So if the horizontal member is experiencing this active force, now because of this active force, there will be some reactions. So now you can see this force head is downward, and this force, which is the actually the reaction, these are upward. So these three forces are parallel. You can see here this force, and this force. These are parallel, but they are not of same sense. So they will be under the category of unlike parallel force. Similarly, the force can be concurrent. So the concurrent force are those forces which originate or which may be applied on a single point. For example, you can see this is the example of concurrent force. So these three forces are originating from a single point. Similarly, this case is the origination. Now, if this is a single point and all the forces are acting on a single point, those are also the category of the concurrent force. So force originating from a single point or force applied, I mean number of forces applied on a single point, they will be called as concurrent force. Now, if there are n number of forces acting on a particular point, we can replace those n number of forces in a single force, which is called as the resultant. So you can see these three forces are replaced by a single force, which is called the resultant. Now, to balance this resultant force, we can apply another force which will be of equal magnitude but of the opposite sense. So you can see, to balance this resultant force, we have applied opposite force. Now this opposite force which will balance resultant force, it is known as equilibrium. So this is the example of parallel force. So as I said, if we are having n number of forces, we can replace those n number of forces with a single force, and that single force will be known as the resultant force. And if we apply, or if we try to balance that resultant force by applying another force which will be of same magnitude but of opposite direction or opposite sense, in that case that force will be known as equilibrium. So the force classification that I was discussing in the previous slide, so we can understand with more clarity from using this diagram. So here in the diagram, I have provided the 7 force system, and now we will take all 7 system one by one, and then we will see whether these forces are concurrent, coplanar, and parallel. So if we consider the first system, you can see the force is along the x direction. So both forces are parallel and they are acting on a single point, and also they are coplanar because they are acting along the xy plane. So now you can see the table. So if we consider the first system, these forces are coplanar. These two forces are parallel to each other. Similarly, they are concurrent because they are acting on the single point. So they are also concurrent. Now we will take example of the second system. Now in the second system, we can say that these three forces are acting along, say if I say this is z-axis and this is x-axis, this is y-axis. So they are acting along the xz plane. So all three forces are acting in the zx plane. So which means these three forces are coplanar, but they are not acting on a single point. they are acting on a, I mean their point of application is different, so they are not concurrent. So I have written here as the, they are not concurrent, but all three forces are unlike parallel force, which means they are parallel to each other. So these are yes, yes. Similarly, if we take example of this one, in this case you can see uh, there are again three forces. Now all three forces are not parallel, so we will say that they are not parallel to each other, but they are acting on a single point, or their point of application is same. So in that case they are concurrent, and also they are acting on the same plane, which is xz plane. So you can see they are coplanar, they are not parallel, but they are concurrent. Similarly, if we analyze the fourth system, now in the fourth system also, this force is acting on the, on this plane. Now again, these three forces are in the same plane, which is xz plane, and but they are not acting on a single point, they are not concurrent, but and also they are not parallel, they are also not parallel, so they are only, we will say that they are only the coplanar forces. Similarly, in case of fifth, now you can see in the fifth case, if I am again right here, this is z, this is x, and this is y. So now you can see the forces are in different plane also. For example, this force in plane of zx, this force is in plane of zy. Similarly, this force is in plane of zx, and this force is in the plane of zy, which means these all these forces are not acting in a single plane, but in two planes. So we will say that all the forces, I mean the whole force system is not coplanar. So that is why in the fifth system I have written here, it is not coplanar. But all the forces are parallel to each other. So yes, they are parallel, but they are not concurrent. Similarly, the sixth case also you can see this force is acting along the z-axis, this is along the x-axis, and this is along the y-axis. So all these forces are again not the coplanar, because they are acting along all three axes. So they are not coplanar, but they are concurrent because they are acting on a single point. So sixth system, it is only concurrent, it is not parallel, and it is not coplanar. Similarly, in the seventh system, it is not a coplanar, not a concurrent, and it is also not parallel. So the seventh system is explaining all three classification. So I hope now this classification of force in terms of coplanar, parallel, concurrent, I hope it is now understood. So now we will continue our discussion in the next part. Thank you.